Alright class, today we are talking about one more place value topic. Our learning target is I can determine the product of a number multiplied by 10 or 100. Before we do that though, let's review these number line questions from yesterday. Most of us did pretty well, but I did have some questions while we were away from our Zoom meetings that day. So let's take a look at these three. Number 1. Number line starts at 3 and 5/10, ends at 5 and 5/10. So remember, always look at your starting and ending number. That means going from this spot to this spot, we've added two whole numbers. So let's see how many spaces we have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 spaces or 10 sections. That means each one of them is actually worth 2/10, right? So going from 3.5, this is my starting point. Remember, I don't count this line. I go one hop to this line. That would add 2/10. That would make this 3 and 7/10. One more hop would add two more. That would be 3 and 9/10. Then 4 and 1/10. 4 and 3/10. 4 and 5/10. 4 and 7/10. 4 and 9/10. And then one more, so add two more tenths, 5 and 1/10. In the second number line from that assignment yesterday, our starting number was 5/10, or half of 1. So starting at 5/10, it ends at 1 and 5/10, right? So we've only gone up 1. So each of these sections, assuming there are 10, which there are, you can actually just look at the picture above and see that it matches up exactly. There are 10 sections. If you're unsure, always count those spaces or the sections, but there are 10. So each one of these steps, if I start at 5/10 and go one step in, that means I'm adding just 1/10 on this line. So from 5/10, I'd go to 6/10, 7/10, 8/10 at that point. And on the third number line, again, there are 10 sections, but you should always count or verify. This number line starts at 1 and 25 hundredths and ends at 2 and 25 hundredths. So the only difference there is one whole number. So it goes up by one whole number. That means each of these steps goes up by how much? Well, let's see where we end up at our point if we count by a tenth. So 1 and 25 hundredths, 1 and 35 hundredths, 1 and 45 hundredths, 1 and 55 hundredths, 1 and 65 hundredths, 1 and 75 hundredths. If I keep going, my next step would be 1 and 85 hundredths, 1 and 95 hundredths, 2 and 5 hundredths, 2 and 15 hundredths, 2 and 25 hundredths. So I completed that number line, all those steps. I know that I have the correct amount. A few reminders. There's one example on screen there. Always pay attention to the starting number and ending number, right? The one above is a little more confusing or a little more challenging because you're dealing with tenths and hundredths, but it only goes up by 1, right? 25 hundredths, 25 hundredths. Only difference is going from 4 to 5. So each of those 10 sections, again, is worth 10 hundredths, or a tenth. Remember, don't count the vertical lines. Count the hops or spaces. I've been trying to get y'all to do that since we started number lines. Don't count the dashes. You'll end up making a mistake somewhere because this first dash doesn't even count, right? That's your starting number. That dash right there is already 4 and 25 hundredths. It's the next step, if I go up to the next line, that's where I'd add my 10 hundredths or tenth and be 4 and 35 hundredths, then 4 and 45 hundredths, then 4 and 55 hundredths at that point. All right, now let's move on to the important topic for today. We are determining products of a number and 10 or 100 using properties of operations and place value understandings. That's just a complicated way to say that you can solve problems where a number is multiplied by 10 or 100. So that's your goal. We want to be able to multiply any number by 10 or 100, and it's really simple multiplying by tens, hundreds, thousands, 10,000s. You'll see why in a second. So if you have an understanding of place value and a little about multiplication already, it's very easy. When you multiply a number by 10, the place value bumps up one spot. For example, if I take the number 4 and multiply it by 10, it becomes 40. When I multiply a number by 100, the place value bumps up 2 spots, right? Here's an example. 8 times 100 is equal to 800. The only trick that you need to remember here, honestly, is adding those zeros, right? Going from 4 to 40, the only change is I've added a 0 in the ones place and bumped that 4 up to the tens place because I'm multiplying by 10. It's got 1 0. So I'm just adding a 0 to my answer. Same with multiplying by 100 or even a number greater than that. If I'm starting with 8, I'm multiplying by 100, it's going to add 2 zeros. So I'm taking that 8, adding my 2 zeros, it's 800. Pretty simple, right? Let's just review some common things you might see. You do have to be careful with those zeros. If your starting number has zeros in it too, you've got to make sure you add on those extra zeros still. But let's start here. Multiplying by 10. If we're multiplying anything by 10, we're just adding a 0 to the end of our number, and that's your answer. 5 times 10 would become 50. 250 times 10 would become 2,500, right? 250 already ends in a 0. I'm still adding my 0 because I'm multiplying by 10. That makes this 2,500. Even larger numbers. This one is 26,874 times 10. Just got to add my 0 to the end. Makes it 268,740. If you are multiplying by 100, you add those 2 zeros, right? So here's some examples for that. 3 times 100 would be 300. Pretty simple. 627 times 100 would become 62,700 because I add those 2 zeros at the end. The number 95,273 times 100 would become 9,527,300 because I've added those 2 zeros at the end. The place value is bumped up 2 times. So just remember the trick. All you have to do is add your zeros to the end. This pattern stays true for larger multiples of 10. If I'm multiplying by 10, 100, 1,000, 10,000, or even 100,000, if I'm taking a number, let's start with a simple digit so we can think about this in our heads. Let's say I have 2 times 100,000. All that's going to happen is I'd have 2, and I'd need to add 5 zeros to the end of it, and it would make it 200,000.